What's happening, dogs? Mr. Allen here with some simplifying of exponential expressions, and these answers should contain only positive exponents. That's pretty standard across the board. So first one here, we got straight up multiplication everywhere. Just because there's that extra multiplication sign doesn't make it any more significant. Someone wrote the problem that way. So let's look at my x's. I've got x to the third, I got x to the first. Well, what do we do when we're multiplying with like bases? X and x are the same base. I add my exponents. 3 plus 1 is 4. So x raised to the fourth power. Y to the fourth, y to the negative seventh. What's that going to be? Well, that will be, let's see here, 4 and negative 7 add up to negative 3. We're not going to be able to leave it like that. We'll deal with it in a sec. Z to the negative second, z to the fifth. Negative 2 plus 5 is positive 3. So we get z to the third. Okay, so now we got to clean it up. Only positive exponents. Where does this guy need to go? We got to create a fraction. X to the fourth, z to the third, divided by y to the third. You could have done that all in one step there. I wanted to show you guys, an extra step, show you what's happening, why it goes that way, and maybe not do too many things at once. Especially when you're first getting started. Take your time, write a couple things down, okay? When you're dealing with exponents and simplifying exponents, make sure it fits one of your 5 properties. Like bases, add the exponents. When we're multiplying like bases, add the exponents. When you're dividing, you subtract. When you have a power to a power, you multiply the exponents. Anything to the 0 power is 1, and negative exponents give us reciprocals. Okay, so those are our 5 biggies. Hopefully, you've got those in your cabeza. All right, next one here. We've got division. What did I just say? Dividing like bases, subtract your exponents. We got x to the fourth, x to the first. I'm going to give myself a fraction here. We may or may not need that fraction. We'll see. 4 minus 1 is 3, so I get x to the third in the numerator. Then I got y to the first. We got y to the third. Well, 3 minus 1 is 2, but where was that larger exponent at? It was in the denominator, so y to the second goes here. Let me recap that. When we're dividing with like bases, I add my exponent. When I'm dividing with like bases, I subtract my exponents, right? Now, in the first part, it was 4 minus 1 is 3. And my larger exponent was in my numerator. Now, in this one, I have y to the third in the denominator. 3 minus 1. My larger exponent was in the denominator, so the result goes in the denominator. So this last one here, I have z to the sixth, z to the first. 6 minus 1 is 5. My larger exponent was in the numerator, so it goes to the numerator. Boom. Final answer. Dope. Fantastic. Wonderful. All right, next one here. This is weird. My watch is telling me to stand. I currently am standing. Is that like a short joke from my Apple Watch? I don't know. All right. Anywho, I'm going to go orange now. All right. So here I've got, there's nothing to do inside the parentheses here other than that z to the zeros is poof, it's gone, it's 1. So I guess I could rewrite this as 3x to the fourth, y to the seventh, all squared. So I like to clean up the inside of the parentheses, if possible, before distributing my exponent in. Here's a common mistake, though. This 3 has an exponent of 1. So that 1 times 2 is 2. It's going to be 3 to the second, okay? 3 squared, or 9. It's not 3 times 2. It's not like we're multiplying numbers now when they're exponents because we got these new properties. No. It's 3 squared, and a way to see that is that's an exponent of 1 on it. Then I got x to the, 4 times 2 is 8. 7 times 2 is 14, so y to the 14th. So final answer here is going to be 9, x to the 8th, y to the 14th. Nice. Cool. Dope. All right. Last one here. We'll call it a day, man. We got ourselves 2xy to the 4th cubed. Nothing to do in here. Nothing to do in here. Let's deal with the exponents that are on the outside. So 2 cubed is going to be 8. X to the 3rd. Y to the 4 times 3 is 12. 5 squared is 25. Then we got x cubed squared. 3 times 2 is 6. And that y is to the first. 1 times 2 is 2. All right. Now let's clean it up. 8 times 25. That's what? 200? 200? 2 Benjis. X to the third. X to the sixth. We're multiplying like bases. Add my exponents. I get x to the 9th. And then we get y to the 12th. Y squared. That's going to be y to the 14th. Boom. All positive exponents. That's awesome. Fantastic. Wonderful. And dope. All right. Hope that helps. I got some more difficult ones as well if you need them, but this is a little more basic, you know, getting started on some exponential simplification. They get kind of crazy, though. Exponentially fun, if you will. See you later.